Reactivity series of metals. Metals which can lose their outermost electrons relatively easily are the most reactive ones. The tendency of the metals to lose electrons is directly related to their reactivities. Although hydrogen is a non-metal, it has been included in the reactivity series. Actually, it behaves like metals and forms positive ion. That is, each positive ion by losing its only electron present. The chemical reactivity of various metals with water or dilute acids is experimentally studied. On the basis of relative reactivity of their reaction with H2O, metals are arranged in the order of their decreasing reactivities as shown in table. As we move down the series, the chemical reactivity of the metals decreases. Platinum is the least reactive metal. Chemical reactivity means the reactivity of metals with oxygen, water or dilute acids. It is an experimental fact and is usually determined by finding the rate of reaction of the metals with dilute acids. Metals like copper, mercury, silver, gold and platinum are non-reactive as they do not react with oxygen, water or dilute acids. Let us learn about reactivity series of metals. Activity series of metals. For arranging these less reactive metals in the activity series, we use the displacement reactions to find out their relative reactivities. The general rule in displacement reactions is that a more active metal can displace a less active one from its salt solution. Let us learn about the reaction of magnesium in zinc sulfate solution. Magnesium is more reactive than zinc, as it is able to displace zinc from the zinc sulfate solution. If a piece of magnesium wire is put in a zinc sulfate solution, the following reaction takes place. The more active metal magnesium displaces the less active zinc from its salt solution. Magnesium in solid state reacts with zinc 2 positive ions in aqueous state to give magnesium 2 positive ions in aqueous state and zinc in solid state. We will now learn about the reaction of zinc in copper sulfate solution. When a zinc plate is put in a solution of copper sulfate, it will displace the copper metal from the solution. As the amount of copper 2 positive ions decreases, the blue color of the solution decreases and finally disappears as copper 2 positive ions gets completely converted into copper metal. Zinc in solid state reacts with copper sulfate in aqueous state to give zinc sulfate in aqueous state and copper in solid state. We will next learn about the reaction of copper in zinc sulfate solution. If you dip a copper plate in a zinc sulfate solution, no reaction occurs. It is because copper, being less active, cannot displace the more active zinc from its salt solution. Let us learn about the reaction of copper in silver nitrate solution. If a copper wire is dipped in a colorless solution of silver nitrate, that is AgNO3, in a beaker, a white shining silver metal is precipitated out and copper nitrate solution is formed. Copper in solid state reacts with a colorless aqueous solution of silver nitrate to give copper nitrate in an aqueous blue solution and silver, which is precipitated out. Copper, being more active than silver, displaces silver from its salt solution. The resulting solution will be blue in color due to the formation of copper nitrate. Let us now learn about the reaction of silver wire in copper sulfate solution. Silver, being less reactive than copper, is unable to displace copper from its salt solution. No reaction takes place. No change in the blue color of the solution is observed. We will next learn about the reaction between silver wire in gold nitrate solution. When a silver wire is dipped in a gold solution, gold metal is precipitated. Silver in solid state reacts with gold solution to give silver ions and gold in solid state. It shows that silver is more active than gold, which is placed below silver in the activity series as shown. Let us now learn about salient features of the activity series. The activity series is a useful guide for predicting the feasibility of the reactions of metals with acids, water, or metallic salt solutions. Metals placed above hydrogen in the activity series are called active metals. Metals placed below hydrogen are called less active or noble metals. Metals above hydrogen in a series react with acids and form hydrogen from dilute acids which has H-positive ions. The more active metals give electrons easily to form M-positive ions. The electrons lost from the metal atoms are easily taken up by H-positive to form hydrogen atoms, which ultimately form hydrogen gas. Less active metals cannot give electrons to H-positive of the acids and hence are unable to displace hydrogen gas from the dilute acid solutions. The higher the metal in the activity series, the more is its reactivity. Potassium tops the activity series and is the most reactive metal. Platinum, being last in the series, is the most unreactive metal. Metals at the top of the activity series are very reactive and therefore do not exist free in nature. Sodium and potassium do not occur free in nature, but as their compounds like sodium chloride and potassium chloride do not occur free in nature. the least reactive metals like gold occur free in nature. A more reactive metal, that is, which is placed higher in the activity series, can displace the less reactive metal from its salt solution. A less reactive metal cannot displace the more reactive metal from its salt solution. The reactivity of metals with oxygen, water and dilute acids decreases from the top to bottom till hydrogen. Metals below hydrogen do not react with oxygen, water or dilute acids. Let us now have a look at an example to understand this better. What would you observe when zinc is added to a solution of iron sulfate? Write the chemical reaction that takes place. And now the answer. When zinc is added to iron sulfate solution, it displaces iron from its salt solution and forms zinc sulfate. This is because zinc is placed higher than iron in the reactivity series. Zinc in solid state reacts with the light green aqueous solution of iron sulfate to give zinc sulfate, which is a colorless aqueous solution, along with iron metal. You can see the solid grey-black iron particles settling down with the disappearance of the light green color in the solution of iron sulfate. Let us take one more example. What would you observe when an iron nail is dipped in a solution of copper sulfate? And the answer is, when an iron nail is dipped in a solution of copper sulfate, the reaction shown on screen takes place. Iron in solid state reacts with aqueous copper sulfate to give ferrous sulfate, which is in aqueous form, along with copper, which is in solid state. Iron, being more active than copper, displaces copper from copper sulfate solution. The blue color of the solution changes to light green color and copper metal is formed. This copper metal covers the surface of the iron nail and the iron nail becomes brown in color.